Today I'm going to show how to perform a multiplex PCR. So first I would start by cleaning my workspace, the workbench. So I'll put on my gloves first. So I'll clean my working space with So I'll also clean my working pipettes with ethanol. So as you can see here, I have my pipettes ready, my 1.5 mil centrifuge tubes. Then I have my nucleus-free water here. Then I have my primers for the PCR. So I have primers for Vibrios, 3 primers for Vibrios, and I have also primers for archaea, bacteria, and eukaryotes. So I'm going to start off first by mixing all primers in a tube. So I'll pick my 1.5 mil centrifuge tubes. So while taking them, make sure as possible not to touch the rim of the tubes. Since I'm working with a lot of primers, so I'm going to make a solution with a total vote for each multiplex PCR reaction. That's for the Vibrios and and also for the multiplex PCR for archaea, bacteria, and eukaryotes. I'm going to have 2 reactions. So in one reaction, I'm going to mix all primers for the Vibrios, and the other on other reaction, I'm going to mix the other 3 primer pair for bacteria, archaea, and eukaryotes. So since I'm working with 6 different primers in total, I'm going to have to make a total volume of 8,000 microliter for each mix. So, and to do that, I'm going to take 100 microliter from each primer forward and reverse. So for the forward primer, 3 forward primer that I'll have for the Vibrios, I'm going to take 100 microliter each from each forward primer. The same thing, I'm going to do the same thing for the reverse primers. So I'll start first by mixing, but first I have to label the tubes to know which is which. So I normally use primer mix 1 and primer mix 2. So primer mix 1 is my Vibrios. So since I have 6 primers in total, I'm going to add 400 microliters of nucleus-free water to each tubes to make up for the volume. So I'm going to take 400 microliters of nucleus-free water. So first I'm gonna make an liquid. to have 400 microliters. So the next thing I'm going to do is to take 100 microliters of each of my primers to the designated tubes that I have prepared for each reaction. So for the videos, I'm going to take 100 microliter from each forward and reverse primer. So when I'm done with the mixing, then I flick the tube for proper mixing and homogeneity. So I flick the tubes and I centrifuge. So now my first mix is ready, and my second mix is also ready. So the next thing I'm going to do is to prepare a master mix for each reaction. So here is my ice box. So you can see in my ice box I have 10 samples labeled S1 all through S10. Then I have my two primer mix 1 and primer mix 2, and my long arm hot start master mix. So here is the calculation I also made for 10 samples. So here I have 11 samples because I added additional 1 to compensate for pipetting errors. So, and my total reaction volume is going to be 25 microliters. So I'm going to start now by making a master mix of the 2 reactions. So I'll label both tubes. So I always start off by adding water to my reaction mix. So I'm going to add 97.9 microliters of water, 98. So I'm going to add that to H2. So I'm going to start by adding 98 microliters of water to each tube. So next thing I'm going to add is my hot start long arm master mix reagent. So I'm going to add 138 microliters of my long arm hot start master mix reagent. Always change tips. So next thing is I'm going to add my primer mix 22 microliters. So for my primer mix 1, which has both which is a mix containing primers for bacteria, archaea and eukaryotes, I'm going to add 22 microliters to my first mix. Then for my for my second reaction mix, which is primer mix 2, I'm going to add a mix made for Vibrios and Vibrio chlorine. So my second reaction mix. So next thing I'm going to do is, since I'm done with the mix for now, except I've not added my template as of yet. So I'm going to flick each tube. Then centrifuge. So the next step is I'm going to dispense my master mix reaction, or the solution mix, to 200 microliter PCR tubes. So since I have 10 reactions for each, 10 samples for each reaction, I'm going to take 20 tubes. So you should be careful not to touch the rim of the tube. Next thing I'm going to do is since the total volume is 25 microliters and I'm yet to add my DNA template, which was meant to be my DNA template that I was gonna add is meant to be 1.6 microliters. So I'm going to subtract 1.6 microliters from 25 microliters, which should give me probably around 23.4 microliters. So I'm going to dispense 23.4 microliters to each tube. So I'm starting with my first reaction mix. Then I'll do the same to my second reaction mix. And lastly, my negative control. Now that I'm done with dispensing the reaction mix, I'm going to add 1.6 microliter of my different samples to each tube. So I'll start with sample 1, which I'm going to add twice because I have 2 reactions. So I'm going to add 1.6 to the first reaction mix, while the second one I'll be adding would be to my second reaction mix for Vibrios. So I'm going to add 1.6 microliters. So when I add, I pipette up and down 2 times. Next, I'm going to add my second sample to both reactions. So I'm adding 1.6, like I said earlier, to both reaction mix. So I mix by pipetting up and down, after which I change my tip. So the second reaction mix by pipetting up and down. So my third sample. Now I'm done adding all my 10 samples. So next thing I'm going to do is for my non-template for my control, which is my NTC sample, my non-template control, I'm going to add 1.6 microliters of nucleus-free water. But it's always better to go one microliter above when you're calculating your total reactions. It's better to always go add another extra reaction to account for pipetting errors. So now I'm going to add 1.6 microliters of nucleus-free water to my control sample. And now I'll mix by pipetting up and down. So the next thing to do is to start I'm going to vortex this and start the reaction. So next thing, after the reaction mix is ready, I'm going to vortex. I'm going to centrifuge. Sorry. The next step is placing it in the thermocycler. So here I have my thermocycler, normal conventional PCR. Now I'm going to add my tubes my labeled tubes to the PCR thermocycler. It's always important to label your tubes to know which reaction mix is which. So now I'm going to set up the on. So I already have my run saved here under my own folder. So here I have everything ready. Then I'm just gonna click on next and start. So now it's done. I'm going to wait for approximately an hour plus. So it's been 1 hour. So after 1 hour, I can take out my samples. And switch off the thermocycler. So if you are planning on working with the samples, like the day you perform the reaction and everything, you can go ahead with the next steps. But if not, if you plan on using the samples tomorrow, either if it's for a sequencing run, it's always advisable to save or store your samples in -80 in the freezer, -80. Then if it's to run on a gel or if it's to run on a gel, you can save in the fridge, in the normal fridge, in -4. So since I'm planning on using this today for a sequencing run, the next thing I'm going to do is to check the concentration of my PCR reaction.